Hello everyone, today we're doing problem 6.24 and this problem asks us to draw the products of homolysis or heterolysis in each indicated bond. So in A we have a homolysis of this carbon-hydrogen bond, and in B we have heterolysis of the oxygen-carbon bond. And it says to use the electronegativity difference to decide on the location of the charges in heterolysis reaction and classify each of the reactive carbon intermediates as a radical, carbocation, or carbanion. So let's look at homolytic cleavage in our cyclohexane. So remember, when we draw a two-headed arrow, so that head of the arrow represents the two electron movements. So this is one electron, this is two electron. So when we draw these double-headed arrows in reaction mechanisms, this is indicating the movement of two electrons. But in a homolytic cleavage, we know that each of the atoms here, so the hydrogen and the carbon, are going to share these two electrons in the sigma bond. So we have to draw half-headed arrows. So we draw one electron going to hydrogen. Remember, the tip of the arrow is your one electron. Then the second electron goes to the carbon. Remember, that's one electron there. So what we're left with now is a hydrogen radical with a carbon radical with this hydrogen still here. So we have a radical carbon intermediate. But now this is telling us it's heterolytic cleavage in B. So we know that the two electrons that make the sigma bond are going to fall on the more electronegative atom. So oxygen vs carbon. Oxygen is more electronegative, so we know that these two electrons, the sigma bond, are going to go onto the oxygen nucleus. And we draw a full-headed arrow because we're moving two electrons this time. So now we're going to draw the intermediate. So we have now this ethane, but now we lost a bond on this carbon. So now this carbon only has 3 bonds. So it's a carbocation because it's positively charged, losing 2 electrons. Why? Those 2 electrons went onto the oxygen nucleus because it's more electronegative.